Hi everyone, tonight we're cracking open the darkest vault of the cosmos the moment before. Moments the birth of time, the first breath of reality. Picture this. You're not floating in space because space hasn't been invented yet. You're not surrounded by stars because stars are just a rumor your atoms haven't even dreamed up yet. There's no up, no down, no left or right. And yet here you are standing at the edge of an almost mythical event that scientists awkwardly call the Big Bang. If you're picturing an old-timey cartoon bomb going off, yeah, toss that out. This was no bang like you know. It was more like a whiteout. A flash of unbearable brightness that didn't just light up the room, it became the room. Everything that would ever exist was squeezed tighter than your holiday jeans after dessert, and then suddenly catastrophically stopped being squeezed. Boom. But not a boom you can hear. A boom of being. You probably won't survive this part, by the way. I mean, you're basically being microwaved by temperatures 1,000,000,000 times hotter than the sun's core. So maybe don't book any lunch reservations just yet. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You blink into a brightness that isn't light. It's existence being born. For a billionth of a trillionth of a second, it's not even clear if anything is happening because the concept of happening hasn't finished loading yet. There's no place for anything to go. There's no before. And yet there's this brilliant burst of... White scientists often describe the Big Bang as a singularity, a point of infinite density, infinite temperature, and zero volume, which is basically a fancy way of saying we don't really know, but it was a lot of something in no space. Now here's a weird fact for you, this white explosion you're picturing. It wasn't white like fresh laundry. It wasn't even visible. The early universe was too hot for light to even be a thing. Photons, the little packets of light, were bouncing around in pure plasma, crashing into free electrons like drunken bumper cars at a physics rave. It took hundreds of thousands of years for that chaos to calm down enough for light to travel freely. But that doesn't mean there wasn't something. In fact, the cosmic microwave background radiation, the afterglow of the Big Bang, is still floating around you right now, like ancient warmth tucked between the folds of the present. You stumble gently into that moment, surrounded by brightness you can't see, heat you can't feel, and silence so loud it could split atoms. If you could hear this moment, which you can't, because sound needs air and air doesn't exist, you'd hear the birth cry of everything. Still, scientists debate what actually caused this moment. Was it quantum fluctuation? Was it the release of vacuum energy? Was it a cosmic burp from a universe that came before? Honestly, it depends on which cosmologist you buy coffee for. One thing's clear, the Big Bang wasn't a bang in space, it was a bang of space. Space didn't expand into anything. It created the anything. So when people ask what's outside the universe, it's kind of like asking what's north of the North Pole. There is no outside. There is only everything, and it's inflating faster than your weekend plans falling apart. And while we're at it, here's your irrelevant but amazing fact. For the evening, cockroaches can hold their breath for up to 40 minutes. Completely unrelated, but I felt like you deserved to know. Just imagine one of them chilling in the Big Bang, holding its breath through the birth of all things. Absolutely thriving. But back to you. Here you are, an imaginary observer curled up like a sleepy particle in this unbearable brightness. You don't need eyes here. There's nothing to see. You don't need time. It hasn't unfolded yet. But you're drifting suspended in this expanding moment, caught between the end of nothing and the start of everything. And though your human mind wants to ask, where did this come from? Be careful. That question is a trap. Before the Big Bang is like asking what's earlier than the first second. The clock doesn't go back any further. Or does it? Some theories flirt with a pre-bang universe, others with parallel bubbles, each with their own Big Bangs popping like cosmic popcorn in a multiversal kitchen. You're free to believe them, or not. Honestly, cosmology is like a box of chocolates, if the chocolates were made of equations and existential dread. But right now, in this white-hot instant, none of that matters. The universe has just gone from does not exist to exists. The scoreboard lights up. The game has begun, and you're here for it. You don't feel heat, not exactly. It's more like pressure. The kind of pressure that could bake a planet out of hydrogen in a blink. You float, and you feel time crawl toward you like syrup. You see nothing yet. You sense everything happening all at once, expansion, creation, unrelenting change. The Big Bang might have been the first white explosion, or it might have just been one in a long, echoing line of cosmic events we'll never fully understand. But it was your white explosion, the one that made you possible. So hold on to that. You shrink now voluntarily or not into a universe smaller than an atom. It's like folding yourself into the crease of a crease, wedging your consciousness into something so compact and overloaded, it makes a black hole look like a lazy sunbather. You're not floating through space anymore because there still isn't any. You are the space. You're pressed against yourself in a way that's uncomfortable to describe on a family-friendly channel. The universe at this stage isn't empty or peaceful. It's more like a party where the DJ just hit the red button and everyone's been liquefied into pure energy. Temperatures are unimaginable, 10 million trillion degrees. Scientists try to write that out with numbers, but eventually just give up and say extremely hot. You might as well be bathing in lava that's been emotionally traumatized and set on fire again for good measure. Particles don't exist yet. There are no protons, no electrons, not even atoms. You're inside a primordial soup so dense and energetic that it's made of raw potential. The stuff that might someday turn into stuff. The universe isn't building, it's vibrating. This thing, this subatomic flashbulb, is roughly the size of a grapefruit. Okay, maybe smaller. A pinhead. A plank length. Imagine fitting all the mass and energy of everything you've ever seen, mountains, stars, entire galaxies, into something smaller than the period at the end of this sentence. No offense, but you'd probably explode just from looking at it. Still, that's where you are. The thing is, this moment is so short, it barely counts as a moment. We're talking femtoseconds here. Blink and you've missed several trillion years' worth of reactions if time was even functioning like we think it does. Which it isn't. Right now, you're living in a place that hasn't figured out the difference between before and after. Physicists call this stage the Planck epoch. It lasts from 0 to 1043 seconds, otherwise known as so short your brain refuses to care. But it matters because in this infinitesimal blip, gravity, yes, the thing that usually keeps your snacks on the table, might be doing something completely unrelated. We think it separates from the other forces here, quietly slipping out of the cosmic stew, like a kid sneaking out of a family reunion. Scientists still debate what the laws of physics even were during this time. Did quantum mechanics rule everything? Was gravity strong or weak? Did time have direction? Was the entire universe just one hyper-condensed math problem desperately trying to simplify itself? Honestly, it's a mystery wrapped in a paradox inside a very spicy burrito. And yet the universe remembers this moment. Sort of. The fingerprints of this phase, its violent expansion, its absurd density, are still smudged across the sky in the cosmic microwave background. You can see the echo of this Planck-sized tantrum if you just look in the right wavelength. It's like catching a baby photo of reality, blurry, loud, and somehow covered in goo. Now here's an irrelevant but true fact for your sleepy head. A blue whale's heart is so large, a small child could swim through its arteries. Not recommended, but definitely a fun image. And while your body lies in bed quietly forgetting the weight of your eyelids, just imagine that child swimming calmly through a whale's veins while the universe explodes into being around them. Anyway, the grapefruit-sized baby universe. It's about to have a growth spurt, like the kind of growth that makes teenage legs ache. In a fraction of a second, it expands faster than the speed of light. This is not just Big Bang energy, it's get out of my way, I'm becoming the cosmos energy. You start to feel pulled. Not by anything you can name, but by expansion itself. It's like someone pressed the inflate button on existence. Distances between any 2 points suddenly stretch like warm bubblegum. It doesn't even need to explode, it's space itself doing the growing. Which means no matter where you go, the rest of the universe is always scooting away from you. Kinda rude. This period is called inflation, and it makes your early universe look like a toddler hopped up on cosmic candy. In an infinitesimal flicker of time, the universe grows from subatomic to something the size of a grapefruit, a planet, a galaxy. You blink again, and it's the size of everything. Inflation isn't just fast, it's horrifyingly smooth. One of the great mysteries of physics is why the universe is so uniform in all directions. It's like tossing 100 billion marbles across a football field and having them all land perfectly spaced. Scientists still debate whether inflation was the only way to make the universe so flat and even, or whether there's some deeply sneaky physics we haven't grasped yet. But you're along for the ride, and it's getting colder. Not cold like a freezer, not yet, but cooler than it was a nanosecond ago. Expansion slows the chaos, temperature drops, energy settles just enough to start doing something new, organizing. Which brings us to your particles. Finally, quarks begin to pop into existence, zipping around like caffeinated gnats, occasionally bumping into each other and deciding, hey, let's make something together. These tiny rebels start forming protons and neutrons. Reality is becoming chunky. You could say it's finally cooking with flavor. And as you hover in this soup of fundamental particles, one thought lingers like steam rising from a bowl, this entire process, this madness, this inflating miracle. All of it started from a single point. No larger than nothing. Just infinite energy folded into silence. And then suddenly there was everything. What came before? What pushed the first domino, we don't know. Not yet. Maybe never. But you're here now. And the universe. It's just getting started. You don't wear a watch here, there's no wrist to wear it on. And even if you had one, it would just spin uselessly, like a confused compass on Jupiter. But still, something has shifted. Tick. Just like that time has begun. It's not loud. It doesn't crack like thunder or boom like a cannon. There's no alarm, no countdown, no opening ceremony. It's more like the quiet click of a door unlocking in an empty house. A subtle beat that wasn't there before is now ever present. Tick, tick, tick. It's not that time was hiding. It simply didn't exist. Not in the way you experience it. There was no before this moment because before only makes sense after time is invented. And now here you are drifting inside that first breath as causality stretches its limbs and yawns into being. Scientists call this the emergence of time. It's part of the universe's soft launch. One moment, reality is a dense blur of energy with no direction. The next, it has an arrow, a way to point forward. Time gets its own flavor. And with that flavor comes something familiar: change. But don't get too comfortable. The universe isn't exactly following a neat schedule. Time in its infancy is like a toddler with too many buttons to push. It doesn't behave. It flickers. It stretches. It loops in places we can't quite see. Some theories suggest time might not even be fundamental. It could be an emergent property, like the way water seems wet even though individual molecules aren't. And scientists still debate whether time flows uniformly or if it only feels that way because our brains are squishy and obsessed with order. For all we know, this ticking could be a local feature like pine trees or overpriced airport sandwiches. But enough speculation. Back to your strange little moment. With time underway, the universe has a new skill: cause and effect. It can do things like after that happens, this happens. It's still not particularly neat about it, but it's progress. The expansion is slowing slightly, like a sneeze tapering off. Temperatures are still horrifying, roughly 1,000,000,000,000 degrees, but no longer unthinkable. And in this cooler, slightly calmer environment, something radical happens. Forces start deciding who they are. In the beginning, the four fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified. A single megaforce, a kind of cosmic smoothie. But now they're going through a breakup. The strong force pulls away first. It's responsible for holding quarks together inside protons and neutrons, basically the glue of the atomic world. You know that warm, fuzzy feeling that keeps your hydrogen from falling apart. Very wholesome. But it wasn't always so cute. During this early epoch, sometimes called the Grand Unification Era, the strong force peels off from the others like an independent artist ditching their boy band. Suddenly, the universe isn't just expanding, it's differentiating. It's finding structure, identity, direction. You're drifting just above this energetic chaos, watching particles collide like they're in a speed dating event for matter. Quarks try out combinations, some stable, some exploding into nothingness, while energy ripples outward, forging new space to fill. And now the cosmic clock starts to matter. Because the longer the universe exists, the more stuff it can do. Structures start to form, not stars or planets yet, but patterns, fields, zones of potential. It's like watching paint dry on an infinite, rapidly expanding canvas. If paint had a PhD in quantum mechanics. Here's a quirky little side note for your sleepy brain: jellyfish have no brains or hearts, yet they've been around for over 500 million years. That's way longer than dinosaurs. They just kind of float around, living their gelatinous best life. You're basically the opposite of that right now, inside the brain of the universe, before it even knows how to think. At this stage, physics is laying down the rules. Some of these rules will become permanent fixtures, like gravity pulling downward or the speed of light refusing to be ignored. Others are still negotiable, waiting for the universe to cool down and commit. And remember, you're not just watching this happen. You're made of this stuff. Your atoms, those sleepy little protons and electrons in your bones, your teacup, your pillow, were forged from this primeval madness. You're not in the universe. You're of the universe, which means you come from the moment when time began. Tick. That sound again. It's not real, of course. Sound can't travel here. There's no air to carry it. But in your mind's eye, you hear it, a distant metronome marking the passage from chaos to coherence. You can almost feel the passage of a second now. It drags itself out of the formless mess and becomes a measurable, usable beat. Time begins to matter because things can now happen and then stop happening. It's a miraculous distinction, Scientists still struggle to fully define what time even is. Some say it's a dimension, like the ones you walk through. Others argue it's an illusion created by entropy, our universe's steady march from order to disorder. A kind of cosmic decay clock. In that version, time is just the universe documenting its own aging. But you're not aging yet. Not here. Here you're timeless in a place that's just begun measuring time. A strange observer floating among energy so dense and violent, it should erase memory itself, and yet, you remember. You remember that first flash of unbearable brightness. You remember shrinking smaller than an atom. And now you feel time beginning to breathe. It's your oldest inheritance. You float there warm and weirdly alert, still reeling from the fact that time just started ticking. And now someone tells you actually nothing exploded. Excuse me. You rewind your sleepy mind a little still, tucked inside your cosmic blanket trying to process this. The Big Bang wasn't an explosion in space. It was more like space stretching, expanding, blowing itself up like a balloon made of possibility. The kind of balloon that doesn't pop, just gets more balloon. See, when we hear bang, we picture fireworks or demolition, debris flying out into air, a loud sound, and maybe a dramatic slow-mo shot with a guy walking away from the blast. But there was no outside for the bang to explode into. There was no air, no silence to shatter. It's not like space was sitting there all calm and quiet, then something detonated in the middle like a sci-fi grenade. No. The Big Bang was space itself coming into being and immediately deciding I could really use some legroom. What exploded wasn't matter, it was distance. Everything was already everywhere, compressed into a single incomprehensible point. Then that point started expanding. Not in space, but as space. It's the difference between painting dots on a balloon and blowing it up. Each dot moves away from the others, not because it's traveling, but because the surface itself is growing. So here you are cozy on your metaphorical dot, stretching farther from every other dot by the second. And that might feel lonely. But take comfort, everywhere you go, the rest of the universe is also moving away from everything else. Solitude is the most universal experience of all. Now, if that makes your brain sweat, don't worry. Even cosmologists still debate whether the Big Bang was truly a bang or just the first breath of inflation. Some prefer the term big expansion. Others go with initial singularity, which frankly sounds like a villain from a Marvel movie. And some very bold thinkers are asking whether it even happened the way we think it did, or whether we're just really good at reverse engineering echoes. Speaking of echoes, scientists detect background radiation from that first moment even now. It's called the cosmic microwave background, and it's like a baby monitor from the nursery of time. Static from 13.8 billion years ago. Not quite a lullaby, but close enough. Here's a fun random science snack to stir into your thoughts. Bananas are technically berries, but strawberries are not. I'll just leave that hanging there for your subconscious to chew on while you ride the edge of space-time. Back in your cosmic cradle, expansion is continuing smooth, unstoppable calm on the outside, but mind-melting if you stare at it too hard. Space is stretching uniformly in all directions. No center, no edge, just more. And you're not moving through it. You are it. Your tiny dot of being is being gently dragged apart by the fabric of existence unraveling like the world's most metaphysical yoga mat. Galaxies are forming later, not because they flew away from a blast, but because the real estate between them grew. And here's a twist for your half-asleep brain to wrestle with. Some theories suggest that even now the universe isn't expanding into anything. There's no outside to expand into. The universe creates the space as it expands. So technically, your bed right now is sitting still in space that's being invented underneath it. That's right, you're not moving. The floor is expanding. Sleep tight. Also, scientists don't know whether this expansion will stop. Some think the universe will keep inflating forever, getting colder, emptier, lonelier. Others believe it might slow down and reverse shrinking back toward a big crunch. And the boldest among them suggest a repeating cycle: bang, expand, crunch, repeat. Like the universe is breathing in centuries. But tonight, you're not worrying about crunches or heat death. You're just hovering blissfully detached in the early aftermath of the most unexplosive explosion imaginable. You marvel at how quiet it is, not because there's no noise, but because silence hasn't even been defined yet. This expansion has no flash, no flames. It's all math and motion and mystery. If anything, it's less like an explosion and more like bread rising in an oven you can't see. Yeasty, invisible, terrifyingly vast bread. And you're the molecule of salt sitting in the crust, wondering what all the fuss is about. So no, the Big Bang didn't blow up like dynamite. It inflated like an idea, a blooming, a soft suggestion that said, hey, maybe we could exist. And that question, that little ripple, it hasn't stopped yet. Colors don't exist yet. Not red, not blue, not even beige. You're floating through the universe's earliest light, and it's nothing you can see. The air isn't dark, it's just not anything. Your eyes, if you had them, would be useless here, like sunglasses at a radio station. Because in these early stages, the universe is too hot, too dense, and way too rowdy for visible light to even form. Instead, you're surrounded by pure radiation, high-energy photons flying around like deranged mosquitoes at a nuclear barbecue. But it's not a barbecue you can observe. It's more like trying to listen to a color. You float through a plasma so thick it's practically opaque. Free electrons are zipping through space, smashing into light particles non-stop, scattering them in every direction. Photons can't go anywhere without crashing headfirst into chaos. This isn't a clear night sky, it's the foggiest traffic jam in physics. And it's hot. Like brain-melting hot. 4,000 degrees Kelvin, please. We're still deep in the millions. At this point, even atoms haven't formed yet. Electrons haven't been captured by any nuclei. Everything's still too twitchy, too hyper. The entire universe is basically a cosmic toddler high on thermonuclear sugar. You drift through it anyway because in your imagination, you're invincible. A detached observer, a curious speck in a universe that doesn't even realize it's being watched. So what does it feel like to float through early light? It's not warm, not like sunshine. It's more like pressure, a tight squeeze from all directions. The kind of sensation you'd get if heat could hug you from the inside out and whisper, "I'm sorry," while rearranging your atoms. Comforting. But in this overwhelming light, there is no color. Why? Because color requires a spectrum of visible wavelengths. And in these early moments, everything is so energetic, so intensely compressed, that the photons are simply too violent. Their wavelengths are too short, way beyond violet, up into the deadly ultraviolet and gamma ray zones. If you saw this light and survived, it'd be a glowing scream. But your body would disintegrate long before you could appreciate the aesthetics. Here's a wild and irrelevant fact, for your bedtime mind shrimp can see more colors than humans. Some species of mantis shrimp have 16 different types of color receptors, while we humans only have 3. So if they were floating through this early universe, maybe they could have appreciated the light show. You're still stuck with black, white, and ow. But don't worry, things are shifting. As the universe expands, it cools. And as it cools, those wild high-energy photons lose some steam. Their wavelengths stretch. The light becomes gentler, softer, less stabby. You're watching in slow motion as radiation gradually shifts from invisible brutality to the early ancestors of infrared microwave, and eventually visible light. But not yet. Right now, you're in a phase where brightness exists without beauty. It's all heat and movement and chaos. Scientists still debate exactly how to describe this period. Some prefer technical terms, baryogenesis, recombination, thermal decoupling. Others go for metaphors, a hot fog, a photon soup, a light storm inside a locked box. Honestly, you could just call it the Great Blinding Soup, and you'd be halfway to a Nobel Prize. But there's something oddly serene about it. Even in its violence, there's order emerging. The cosmic plasma is beginning to calm. Electrons are starting to flirt with nuclei. Hydrogen is on the horizon. Structure is creeping in. And here's the kicker. Even though the universe is expanding and cooling, it's still glowing. That initial white explosion might be invisible, but it left behind the cosmic microwave background, the fossil light of creation. A kind of eternal ghost flash that still hums through the universe today, gentle, uniform, and everywhere. That glow, you can actually see it now with the right kind of telescope. Not with your eyes, but with instruments that can read those soft microwave whispers from the past. It's the universe's baby picture, blurred by time, but undeniably real. This early radiation has been cooling for billions of years, stretching itself thinner and longer until it's no longer dangerous. Now it's just background noise. But it's the most important background noise you'll ever not hear. And it's everywhere. In your living room, in your socks, gently touching your skin. It's not creepy, it's history. You are literally bathed in the faded light of creation every moment of your life. So next time you flick on a lamp or glance at your phone screen, remember, light had to fight hard to get here. It was trapped for hundreds of thousands of years, strangled by electrons, scattered into oblivion. And somehow, against all odds, it made it out. You're floating in the middle of the journey. A universe that doesn't yet look like anything. A brightness without color. A heat without flame. A fog of photons that haven't yet found their groove. And yet everything that you'll ever see, sunsets, fireflies, auroras, old photographs of disco clubs, all of it will eventually descend from this. So no, the early universe didn't look white. But oh, it was blinding. You blink metaphorically, and the universe changes color not all at once, not like flipping a light switch, but gradually like the slow fade of a bruise or the soft shift of sunrise through fog. And what color is the universe now? Beige. That's right. Beige. The official color of everything the entire visible universe averaged out is not celestial sapphire, not cosmic violet, not galactic chrome. It's cosmic latte, a warm, unenthusiastic tan. Scientists actually figured this out, by the way. In 2002, a team of astronomers studying the light from over 200,000 galaxies tried to determine the average color of all that combined starlight. After some awkward color calibration and a few tweaks at first, they thought the universe was turquoise, trendy, but incorrect. They settled on this pale, slightly yellowish off-white. Something between almond milk and antique parchment. Very calming. You float through this developing beige, basking in its comforting mediocrity. It's a cozy place to be. The kind of background color you'd paint your living room if you didn't want guests to think too hard about your personality. But beige is a big deal. Because beige means light is finally doing something interesting. It means stars are coming. Galaxies are coming. It means the early universe is no longer just chaos and radiation. It's turning into a space you might eventually recognize. Something you could someday point at and say, yep, that's a thing. You're hovering around 380,000 years after the Big Bang now. Still a toddler in cosmic terms, but already capable of astonishing beauty. Because this is the moment light finally breaks free. Before now, photons were stuck bouncing around inside a dense plasma, slamming into electrons, like ping-pong balls in a wind tunnel. But as the universe expands and cools, something magical happens. Electrons begin to settle down. They start orbiting nuclei. They form actual atoms, mostly hydrogen, with a dash of helium and a whisper of lithium just to keep things spicy. And with that shift, the fog lifts. Suddenly, light is no longer being scattered every which way. It can travel. It can move in straight lines. It can exist independently. This moment is called recombination, though it's a terrible name because nothing is actually recombining. It's more like first combinations. But science doesn't always win at branding. Still, this is when the universe becomes transparent. You float through it, watching the fog clear, and for the first time, light can move freely through space. If you were actually there, somehow immune to death, by heat and gravity, you could see for the first time. You could watch photons soaring across billions of miles uninterrupted, like tiny messengers from the beginning of time. And those same photons, they're still out there. Some of them hit Earth every day. Some of them pass through your bedroom while you sleep. They're the cosmic microwave background we mentioned before, soft ancient radiation, the color of faded sunlight whispering across the sky. Here's something irrelevant but wonderful to tuck into your brain. Fold's wombat poop is cube-shaped. No one asked, and yet now you know. You're welcome. Back to the beige. The average color of the universe is a kind of gentle middle ground between the hot blues of young stars and the cooler reds of old ones. It's a mix of every visible wavelength, like dumping all your paints into a blender and hoping for a masterpiece. The result is beige, and that's okay. Beige is the color of compromise, of quiet maturity. The universe is entering its stable post-toddler phase. No more screaming plasma tantrums. No more existential explosions. It's still expanding, yes. Still evolving. But it's finally calm enough for complexity to grow. You float past forming gas clouds, swirls of neutral hydrogen pooling together under gravity's patient hand. These clouds will someday birth galaxies, though right now they're just dreamy, slow-spinning proto-structures. You see space beginning to take on familiar texture, patches of denser gas, areas where matter is beginning to clump. Tiny fluctuations in the background radiation are sowing the seeds for everything: stars, planets, black holes, coffee tables, frogs. It all starts here, and scientists still debate why those fluctuations existed. Some say quantum jitters from the inflationary period got stretched and magnified. Others suggest that maybe the early universe was never perfectly smooth to begin with. Regardless, those little bumps, imperfections in the fog, will eventually grow into everything. Everything. You're adrift in a soup that's becoming structure, a sea that's becoming stars. The temperature is now a comfy 3,000 Kelvin, still too hot to roast marshmallows, but tame enough for atoms to survive. It's like the universe took a deep breath, sighed, and said, "Okay, I think I'm ready to make stuff now." And as you slowly drift across this ever-growing expanse, wrapped in cosmic latte light and early hydrogen dreams, one quiet fact hums in your ear. This is the moment light began its journey to you. Every photon that's ever reached your eye, every glimmer of starlight, every sunset, every flickering candle owes its existence to this moment. The fog lifted. The universe cleared its throat, and light at last was set free. You're drifting now in something with texture, finally. Not the jagged kind like rocks or bones, but a smooth, soupy turbulence. A kind of chunky fog. You're swimming, if you can call it that, through the early universe's most chaotic recipe, the quark-gluon plasma. It's a hot mess, literally. This isn't soup like Grandma makes, it's more like boiling fireworks. Quarks, the tiny particles that will someday form protons and neutrons, are zipping around at near-light speeds. Gluons, their wild chaperones, keep them tethered together in an endless cosmic dance. It's like a rave where nobody can leave the dance floor, and the DJ is physics itself. Right now, you're inside the quark epoch, a phase of the early universe that lasts from about 1012 to 10.6 seconds after the Big Bang. Which means, yes, it's all happening faster than you can blink, sneeze, or even think about blinking while sneezing. Quarks come in 6 flavors: up, down, strange, charm, top, and bottom. Why are they called flavors? Because particle physicists have a flair for drama and low blood sugar. Most of the ones around you are up and down quarks, the ones that eventually settle into forming protons and neutrons. The others, just there for a good time, not a long time. But you're not just watching. You're soaking in it. The quark-gluon plasma is dense, so dense that no particle can form a stable bond yet. It's like watching puzzle pieces try to lock together in a wind tunnel. Quarks collide, bounce apart, recombine, separate again. It's chaotic, frenetic, and hot enough to make the surface of the sun look like a cool beverage. But slowly, imperceptibly, things start calming down. Temperature drops. The universe expands. Space becomes just a tiny bit roomier. And that's when it happens. Some of the quarks, those reliable up and down types, finally stick together in stable threesomes. 2 ups and a down, you get a proton. 2 downs and an up, that's a neutron. The very first building blocks of matter, the things you'll eventually be made of, form right here in the soup. It's kind of poetic, really. Out of the most chaotic phase, imaginable stability emerges. Order from entropy. It's like the universe took a deep breath, stopped flailing, and decided to start building things. Also, odd fun fact for your brain to hold, there's a species of jellyfish that can age backwards. Turritopsis dohrnii, a tiny sea creature, can revert to its younger form when stressed. So somewhere in Earth's oceans, a jellyfish might be Benjamin buttoning its way through existence. Unlike quarks, which are decidedly one way. As you watch more protons and neutrons appear, you begin to notice structure forming, not complex structure, but consistency. The universe is still a plasma, but it's starting to act like it has rules. Quarks aren't just ricocheting randomly anymore, they're binding into larger units. The strong nuclear force carried by those hyperactive gluons is finally winning its battle. It's what holds the cores of atoms together. Without it, everything would fall apart. You, your tea, the moon, all just scattered fluff without this unseen force gluing matter into place. And here's where things get a little bittersweet. For all the forming going on, not everything sticks. Some particles annihilate each other. Matter and antimatter pairs cancel out, disappearing in puffs of energy. For every billion particle-antiparticle pairs, one lonely matter particle remains. And that's what you are: cosmic leftovers. Scientists still debate why matter won this battle. Why didn't antimatter come out on top, or at least break even? The math suggests it should have been a tie. But clearly, someone cheated. The universe has a bias, and thanks to that little imbalance, you have legs, and bedsheets, and existential anxiety. So what's happening around you now is nothing short of miraculous. You're watching particles choose sides. The soup is separating. Energy is becoming matter. The fog of pure radiation is cooling into a reality where things can exist. And not just things, but you. The protons and neutrons floating through you now will eventually clump into atomic nuclei. Those will attract electrons. Those will build atoms. Atoms will form stars. Stars will cook up heavier elements. Those elements will birth planets and eventually soft little creatures who wonder why their dog stares at walls for no reason. It all starts here, and this plasma, it's gorgeous. Not in a way your eyes could see, there's still no color here, not really. But you can feel the motion, the push and pull, like a tide, like breath, like the rhythm of a universe slowly learning how to be itself. It's not quiet either. You can't hear it, not literally, but the energy fluctuations, the tiny oscillations rippling through this quark-gluon stew are sound waves in a way. Deep, slow, thudding waves of pressure moving through the plasma like the heartbeat of the cosmos. Later, these ripples will echo through space as density fluctuations patterns that dictate where galaxies will eventually form. So when you look up at the stars, you're really seeing the fossilized outline of these early murmurs. You are drifting through the first hints of harmony. The soup thickens. The dance slows. Particles begin to settle into roles. And for the first time in the history of everything, you could draw a line around a proton and say, that's a thing. And that thing, it's your future. You're floating now through a moment so brief it practically doesn't exist, a billionth of a second. That's how long this next shift takes. But in that fraction of time, the entire architecture of reality is rewritten. You wouldn't know it from the vibe. Everything still feels like a chaotic lava smoothie of particles, pressure, and radiation. But if you were able to freeze time and peer underneath the surface of everything, you'd see something crack. The fundamental forces, those quiet puppet masters behind everything from gravity to magnetism, are having a cosmic identity crisis. In the first few flickers after the Big Bang, all the forces were unified. Just one big force blob. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force were all just one weird physics cocktail. No separation. No individuality, just vibes. But now the vibe shifts. The electro-weak force, a hybrid of electromagnetism and the weak force, suddenly splits. Boom, two distinct forces. You might call it a symmetry breaking, though it's less like snapping a twig and more like the universe quietly realizing, I think I'm going to keep my electricity and my radioactivity separate from now on, thanks. And it's this splitting, this sudden decision to define things that allows matter to behave differently. Forces start applying themselves in new ways. Some particles now feel one force, but not the other. Mass starts to show up where there wasn't any. The rules become more rule-ish. And this is the moment when the Higgs field turns on. Ah, yes, the Higgs. The invisible molasses that fills all of space. As particles move through it, some of them start to slow down and gain mass. Others, like photons, just slip right through untouched. It's like an exclusive velvet rope party, where only some particles get dragged back by cosmic bouncers and asked, "Hey, how heavy are you really?" The Higgs boson, the particle connected to this field, won't actually show up for billions of years in a human-made collider. But the field itself is already switched on, gently deciding what will be fast and light, and what will be slow and chunky. So here you are, drifting, invisible, weightless, and suddenly the concept of mass is born around you. And just like that, everything feels more real. Mass means inertia. Mass means gravity now pulls harder on some things than others. Mass means things can collide, clump, orbit. It's like adding texture to a blank canvas. And yet, it all happened in a billionth of a second. That's shorter than the time it takes a camera shutter to click, shorter than the time between two musical notes in a fast jazz solo. but long enough to change the universe forever. Still, scientists aren't totally sure what caused this force splitting or how the Higgs field turned on. Was it a quantum fluctuation, a thermal phase change, a bored god? Who knows? Scientists still debate the mechanisms behind electroweak symmetry breaking like it's an unsolved heist movie, except with math and much worse catering. Here's your palate cleanser. Fact sloths can hold their breath longer than dolphins. Yup, they slow their heart rate so drastically while hanging out underwater that they can outlast a dolphin's dive. Sloth supremacy. Just something to keep in your brain while the forces of nature reinvent themselves. Back in the young universe, things are getting more structured. Now that mass exists, particles behave differently. They bunch, they tug, they scatter with more drama. Protons and neutrons freshly born from quarks now start feeling a hierarchy. Electrons, which are much lighter, buzz around them like annoyed bees without anywhere to land yet. The weak force, now officially its own thing, takes over some strange tasks, like enabling radioactive decay and allowing neutrinos to pass through everything like ghosts who refuse to RSVP. And gravity, our old friend, has already split off earlier, right after the Planck epoch. It's still the weakest of the four forces, but it's also the most stubborn. You can block light with your hand. You can stop electricity with rubber. But you can't hide from gravity. It'll find you. It's the Liam Neeson of fundamental forces. All four forces are now out in the open. Gravity holds space together. Electromagnetism keeps atoms from unraveling. The strong force binds the inside of nuclei. The weak force lets radioactive stuff be well radioactive. And thanks to mass, these forces now apply themselves more selectively. Some particles zip freely, others drag, some decay, others remain stable, and all of it happened in a single blinking moment. And what do you feel in this sea of forces, oddly enough, calm? Not peace exactly. There are still random annihilations and energetic collisions every nanosecond, but things have calmed down compared to the screaming chaos of the first instance. Now there's pattern, function, meaning. You drift past a field of electrons, idling like fireflies in thick molasses. You brush against the invisible edge of the Higgs field and feel resistance just a little. It's not pain. It's not even touch. It's gravity with a smirk. Like the universe whispering, "You're not weightless anymore, champ." And even though stars won't form for millions of years, and galaxies won't take shape until much later, the groundwork is done. The universe has mass. The forces have names. The rules are settling in. And somewhere in this soup, a few lucky particles will someday become you. You're drifting through the leftovers now. The wreckage of a cosmic battle that didn't make headlines, but absolutely determined the future. It was a fight between matter and antimatter. And spoiler alert, you're made of the winner. Let's rewind. A moment ago, you watched particles form protons, neutrons, electrons. But every time one of those blinked into existence, its evil twin arrived too, an antiparticle. Identical in mass, opposite in charge, and probably way more dramatic in a soap opera kind of way. A proton, it gets an antiproton. An electron, it gets a positron. Even neutrinos get shadowy siblings, though they're so elusive you could swear they're making it up. At first, it was perfectly balanced, as all things shouldn't be, apparently. For every particle of matter, there was one of antimatter. That's just how early universe physics rolls. And when they met, boom, they annihilated each other in a burst of energy. Poof. Gone. A flash, a sizzle, and no leftovers. Romantic, really. But then something weird happened. Matter won. Somehow, someway, there was just slightly more matter than antimatter. Like for every billion pairs that destroyed each other, one lonely, scrappy particle of matter survived. It's like a cosmic Hunger Games, but with no tributes, no districts, and no Katniss, just physics being lopsided. Why nobody knows. Scientists still debate the reason for this baryon asymmetry, which is a fancy way of saying we have no clue why anything exists instead of everything being vaporized instantly. Maybe there was some kind of CP violation, a weird little glitch where particles and antiparticles behave ever so slightly differently. Maybe it was the Higgs field playing favorites. Maybe some long-lost fifth force decided to nudge the scales. Or maybe the universe just rolled the world's tiniest, most significant dice. Whatever the reason, the particles that didn't get zapped in the great matter-antimatter war became everything. You, me, moon rocks, Tupperware, K-pop albums, all of it. You're drifting through the aftermath now. It's oddly peaceful. The radiation left over from the annihilations is still glowing all around you, soft and warm, like the embers of a fire that nearly destroyed all of existence but decided to take a nap instead. You bump gently into a lone proton. It buzzes with purpose, as if it somehow knows it made it. That it's part of the 1 in a billion club. Survivor, founder, hero. This proton, and the countless others like it, will go on to form the hydrogen atoms that power stars, that fuel fusion, that eventually get locked into your DNA. It doesn't know that yet. It's just trying not to explode. Here's your irrelevant but delightful bedtime fact: honey never spoils. Archaeologists have found pots of perfectly edible honey in Egyptian tombs over 3,000 years old. So technically, if the ancient Egyptians had invented space travel, they could have brought honey into the early universe, and it would still be fine today. Sticky, but fine. Back in the particle fog, things are changing fast. Now that the antimatter threat is mostly wiped out, the surviving matter starts to pair up more freely. Electrons loop lazily around protons, forming the first hydrogen atoms. Neutrons, not as stable on their own team, up with protons to make helium. A little bit of lithium shows up too, because the early universe loves a good trace element. This whole era is called Big Bang nucleosynthesis. It lasts just a few minutes, 3 to be exact. But during those few minutes, the universe cooks up almost all of the primordial elements it will ever have. No carbon yet, no oxygen, no iron. You'll need stars for that. But hydrogen and helium, those are your starters. The funny thing is, you still see this ratio today. Roughly 75% hydrogen, 25% helium, and a smidge of lithium, exactly what you'd expect if those first 3 minutes went just as planned. It's one of the strongest confirmations of the Big Bang model. The universe basically left behind its first recipe and stuck to it. And you drifting among these atoms begin to notice something odd. Things are slowing down. Not stopping, but calming. The universe is still expanding, yes. Still cooling. But it's becoming stable, predictable, chill. Kind of like when a wild party finally runs out of Red Bull and someone brings out tea. It's around this time you realize something profound. There's no more antimatter to fight. The war is over. Matter has inherited the cosmos. And in a very real way, you are the result of that cosmic glitch. A random imbalance. A 1 in a billion mistake. You are the mistake that kept happening. Scientists still puzzle over it. They've built particle accelerators to recreate those early conditions, hoping to spot the tiniest hints of bias. But the truth is, we might never know why matter won. We just know that it did. And that without that tiny, inexplicable advantage, there'd be no one here to ask why. You drift on, surrounded now by young, timid atoms. Not yet stars. Not yet galaxies. But whole quiet and ready. They don't know what's coming. Gravity hasn't started clumping them yet. The night sky doesn't even exist. But the war is over. The survivors are in place. And the universe is finally starting to breathe. You drift now toward a question so big it doesn't fit neatly into science textbooks. It pulses under your pillow like a quiet riddle humming through every galaxy, every atom, every beat of your resting pulse. Did another universe die so this one could be born? You float just outside the realm of certainty, where physics turns from equations into poetry, and where the early universe, hot and young and messy, might just be the rebound of something that came before. It's called the Big Bounce. And no, it's not the name of a dance craze from the 1970s. It's one of many bold theories that suggest our universe is not the first, and maybe not even the only show in town. You've probably heard of the Big Bang, but what if there was a big crunch before it? A previous universe full of stars and wonder and weird little alien frogs that collapsed in on itself until it reached a singularity, and then bounced back out again as this universe. Some theories propose that space and time are cyclical, that universes expand, contract, and regenerate endlessly, like cosmic lungs inhaling and exhaling across eternity. If true, then the Big Bang you've been floating through might not be a beginning at all, but a continuation. A heartbeat in an infinite loop. The white explosion of this universe might just be the death scream of the last one wrapped in soft, rebounding physics. And here's the thing we don't know. Scientists still debate whether the universe had a clean start at the Big Bang, or whether something existed before. We don't have a time machine yet. But we do have math. And some of that math says time might have no beginning. It just was. Forever. You're floating now on the edge of that forever. The air, if there were air, would feel different here. Taut, pregnant with possibilities. It's the kind of place that asks big questions but refuses to give small answers. And just to throw your sleepy brain a curveball, some quantum gravity theories like loop quantum cosmology suggest that time reverses before the Big Bang. So the universe contracts, then flips, and the arrow of time starts pointing forward again. Like the universe slipping on its jacket inside out and pretending it's a brand new outfit. What's before the beginning, a different kind of ending. Let that sit with you as the stars slowly start to plan their entrance. Of course, there are other theories too. Multiverse theories suggest that our universe is just one bubble in a vast cosmic foam. Maybe new universes are constantly inflating into existence, each with different physical laws. One might be made entirely of elbows. Another might run backward in time. Another might be nothing but ducks. It's possible that this universe's Big Bang was triggered by the collision of two other universes in a higher dimensional space, a gentle cosmic fender bender that spilled space and time across the void. Or maybe, and this one's oddly comforting, maybe our universe emerged from nothing. Not as in empty space, but as in true absolute nothing. No laws, no vacuum, no rules. Just the sudden improbable eruption of something into existence because it could. Because that's what quantum mechanics does sometimes. You're hovering between all these maybes, all these possible pasts. The current universe, your universe, is still hot, dense, expanding. But just behind the veil of plasma and early light lies this haunting truth: we don't know where we came from. And yet you're here, conscious, curious, floating in bed under a ceiling shaped by gravity in a body made of stardust, with thoughts forged from particles that survived annihilation in a cosmos that may or may not have lived 1,000 lives before this one. That's not terrifying, it's soothing. Because it means you don't have to solve it all. You just have to exist in it. You're part of the puzzle already. You're what the universe is doing right now in human form. Also, for no good reason, a day on Venus is longer than its year. That's right. Venus takes 243 Earth days to spin once on its axis, but only 225 days to orbit the Sun. So if you lived there, you could theoretically celebrate your birthday before finishing a full Tuesday. Weird planet. Back here in the young cosmos, expansion continues. The Big Bang is no longer a flash, it's a legacy. And whether it was sparked by a previous collapse, a spontaneous quantum fluctuation, or a hyperdimensional collision, the result is clear. You are living in the echo of a white explosion. Whether it was first or 50th doesn't matter as much as this, it worked. Stars will come. Planets will form. Life will blink open its eyes. But for now, in this early moment, just listen to the silence between universes. The quiet that might have followed a collapse. The breath that came before the bang. The pause between eternities. You're in that pause now. You float now with your eyes closed, or maybe open hard to tell really, since there's still no starlight. No glimmer, no twinkle. Just pressure warmth and an eerie resonant hum that you can't quite hear, but you feel it. Because what's filling the universe now isn't just matter and radiation. It's sound. Not the kind that rattles windows or sings lullabies. Not vibrations in air. There's no air. But still waves ripple through the dense plasma, rising and falling like breath through water. These are acoustic oscillations, the universe's first murmurings. Not made with voices, but with pressure. This is the cosmos's first cry. And what's truly wild is we can still see that sound. Billions of years later, those ancient waves, compressions, and rarefactions in the plasma left behind imprints in the cosmic microwave background. Faint rings, tiny variations in temperature and density, like the ripples left on a pond long after the stone has sunk. If you had superhuman ears the size of galaxies, and let's pretend you do because why not, you'd hear the universe's newborn song. Deep, low. A kind of bass note stretched across hundreds of thousands of years. A single B-flat 57 octaves below middle C, so low in fact that it cycles roughly once every 10 million years. It's the slowest music imaginable, and it's still playing. Scientists call these baryon acoustic oscillations, which sounds like a prog rock band from the 70s, but actually refers to the rhythmic fluctuations in the density of matter caused by sound waves in the early universe. These waves shaped how galaxies would eventually cluster. Even now, if you look at the large-scale structure of the cosmos, you can still see the echo of those notes. So yeah, you're floating in a symphony. You're not hearing sound, you are the sound. It gets more beautiful the deeper you go. Because this hum, it's not just random, it's full of information. Encoded in these waves are the fingerprints of the universe's earliest moments, the tone, the tempo, the texture of creation. And later, using data from missions like Planck and WMAP, scientists mapped those ripples. Like cartographers of silence, they read the faint music of the cosmos and pulled out its secrets. Your bed tonight rests in a pocket of that echo. Your lungs rise and fall to a beat set before stars were born. And while we're on the topic of vibrations, here's your out-of-nowhere fact of the night cats purr at frequencies between 25 and 150 hertz, which happens to promote tissue regeneration and healing. Some researchers think cats may have evolved their purring not just for communication, but as a kind of internal therapy. The universe had sound before light. Cats had healing before science. Everything's been humming for a very long time, back to the early universe. These pressure waves moved through plasma like ripples through honey. They pushed particles around. They stacked matter in patterns. They made some areas denser, others thinner. It's like a sponge slowly inflating from the inside out, sculpted by vibrations. And eventually, When the universe cooled enough and atoms formed, the waves stopped traveling. The fog lifted, light broke free, and the sound became frozen not in audio but in structure. The loudest concert in history ended, and the universe became quiet but full. The pause between beats. Scientists still debate how those early acoustic features shaped galaxies exactly. Did some structures resonate more than others? Were there harmonic frequencies? Could we be missing subtle musical signatures in the deep background radiation, like notes only the universe could hear? You feel a tug in your chest now because deep down you understand the universe isn't just expanding, it's singing. Even your body, a lumpy, sleepy, brilliant arrangement of stardust, is tuned to frequencies. Your brain waves, your heartbeat, the way you hum in the shower. It all ties back to these first vibrations. The Big Bang wasn't just a burst. It was a beginning in rhythm, and it's not over. The background hum never stopped. It's all around you now, curling through your pillow, whispering through the gaps in the walls, bouncing gently off the moon and coming back down as silence. It's not silence. It's just too slow for ears to understand. So tonight, as you rest, you're lying in harmony with the universe. You're swaying gently inside a note that started before time was measurable and hasn't resolved yet. No key change, no chorus. Just the longest, slowest symphony imaginable. And somewhere, if you could listen long enough, with enough patience and enough stillness, maybe you'd catch the melody. Just once. You're drifting now toward a kind of soft revelation. The fog is lifting literally. For hundreds of thousands of years, light has been trapped, scattered by free electrons, like an over-energized disco ball in a blender. But suddenly, finally, something shifts. The photons are set free. Welcome to the era of recombination, the moment when light becomes light in the way we understand it, traveling freely, cleanly, uninterrupted through space. And no, this isn't just a poetic phase. It's the moment the cosmic microwave background is born, the first photograph of the universe, a blurry, beautiful baby picture of everything. You're gliding through it now, surrounded by photons that haven't touched anything in over 13 billion years. They're still here, still traveling. Some of them are bouncing off your forehead as you lie in bed, gently, quietly. Warm, cosmic echoes from a time when light first escaped the womb of the universe. And it only took, 380,000 years. Before this moment, the universe was too hot and too crowded. Electrons were flying solo, unattached to nuclei, constantly smacking into photons and messing up their paths. It was a photon mosh pit. Visibility zero. But as temperatures drop to around 3,000 Kelvin, electrons begin to settle down. They join up with protons, forming neutral hydrogen atoms. No more free-roaming electrons. No more endless scattering. Suddenly, photons can move. And move. They do across space, across time, across dimensions. They're still moving. You're inside that light right now. Every microwave oven, every satellite dish, every radio telescope, they all pick up traces of that ancient freedom. You could call it the moment the universe became transparent. And transparency changes everything. Now photons can travel unimpeded. They start forming the background glow that fills all of space, the same glow we use today to understand how the universe looked when it was only a few 100,000 years old. It's like finding a grainy, static-filled security camera clip of the cosmos at its first birthday. Here's something cozy and irrelevant. Octopuses have 3 hearts, and 2 of them actually stop beating when they swim. Which means an octopus can never go for a jog without a minor heart crisis. Still, they carry on, just like these photons. Back to the light. The recombination process doesn't happen all at once. It unfolds gently like a sunrise. As hydrogen forms across vast distances, a transparent window begins to stretch open across the universe. And through that window, the first light slips out. This light is still here, cooler now, stretched into microwaves, but otherwise untouched. If you ever hear about the oldest light in the universe, this is it. It's not metaphor. It's real. You can point a detector at a random patch of empty sky and still hear its gentle hum. It's everywhere, even in the space between your fingers. Scientists mapped this glow with jaw-dropping precision. Projects like COBE WMAP and Planck turned the sky into a color-coded time capsule. What did they find? A nearly perfect pattern, smooth, consistent, and shockingly even, but with tiny fluctuations. Tiny bumps and wrinkles, temperature variations as small as 1 part in $100,000. And those tiny wrinkles, they're the seeds of everything. They're the places where matter was just a little denser, where gravity started tugging just a little harder. Over time, these subtle differences turned into galaxies, stars, black holes, trees. You, that weird dog down the street. You are a wrinkle in the afterglow. Scientists still debate how those fluctuations came to be. Quantum jitters, inflationary residue. Ghosts from another cycle of the universe. Whatever the source, they were enough. The universe was no longer just light and plasma. It had shape, direction, potential. And once the photons are free, they don't stop. They travel, they inform, they create shadow and contrast. With free-moving light, the universe begins to see itself. And maybe, just maybe, it starts to reflect. This light isn't dramatic. It's not a flashbang or a spotlight. It's more like a low, soft glow. The universe is still cooling, still expanding. But now it's also illuminating itself just a little. It's the dawn of visibility. You float in this expanding sea of photons in a place that's quiet but alive. It's like watching the first candle flicker in a room that had only known heat without vision. For the first time, the cosmos can see itself not through eyes but through openness. And that's the thing. Before this moment, light had never traveled a straight line. It had been bouncing, scattered, caught. And now it's been moving undisturbed for over 13 billion years. Some of those photons, some of those very photons, are touching your pillow as you lie here. That's how close you are to the beginning. And light, it's just getting started. You drift now in a calmer cosmos. The chaos has cooled. The fog has lifted. The early universe, once a furnace of fire and fury, is now a vast sea of hydrogen, helium, and soft background light. But for all this peace, it's a little boring. There are no stars, no planets, no galaxies. Just a dark, expanding emptiness filled with invisible structure and sleepy particles waiting for gravity to get on with it. Welcome to the cosmic dark ages. It's a misleading name because it wasn't sinister or evil, just unlit. The light from recombination still glowed, yes, but it was stretched, dimmed, and mostly invisible. There were no bright points in the sky. No flickering, no sparkle. Just the whisper of hydrogen atoms tumbling gently through space, bumping into each other like tired shoppers in an endless grocery aisle. This era lasted for hundreds of millions of years. If the Big Bang was the spark and recombination was the first breath, then the Dark Ages were the nap that followed. The universe was asleep in a sense. Dreaming of stars it hadn't built yet, but not idle. Because while everything seemed still, something was brewing beneath the surface. Gravity was at work. Remember those tiny fluctuations we talked about in the cosmic microwave background? Those slight overdensities in the early plasma soup, gravity noticed them, and like a patient spider, it started pulling matter toward those spots. Slowly, quietly, you float through this unseen knitting of space where regions of slightly denser hydrogen begin to clump together. Little pockets form, the seeds of structure. Think of them as invisible potholes in the fabric of the universe. Matter just can't help but roll into them. These clumps will become dark matter halos, enormous scaffolds, that ordinary matter like hydrogen and helium will start to fall into. And yes, we're talking about dark matter now. Nobody knows exactly what it is. It doesn't emit or reflect light. You can't see it, touch it, or bounce particles off it like a ping-pong ball. But it's there, shaping galaxies, anchoring clusters, making up about 85% of the matter in the universe. Scientists still debate what dark matter actually is. WIMPs, axions, primordial black holes. A bug in the simulation, pick your favorite theory and write a thesis. The fact remains, it's real, and it matters. And right now, during these cosmic dark ages, dark matter is winning. It's forming the invisible skeleton of the cosmos. Ordinary matter is just tagging along like streamers draped over invisible bones. Here's a cozy little fact to curl up with. There's a species of moss that can survive unprotected in space. It's called Fiscomatrella patens, and it survived a 10-day trip outside the International Space Station with no air-intense radiation and extreme temperatures. Basically, it did better than most astronauts would. The universe breeds tenacity in the strangest places. Back in the darkness, things are getting interesting. As matter continues to clump, some regions grow more dense than others. Gravity pulls harder, gas compresses, temperatures rise, and at the heart of these densest clouds, something ignites. The first stars are born. They're not like the ones you know today. These are population 3 stars, the first generation. Massive, short-lived, made almost entirely of hydrogen and helium. No metals, no carbon, no oxygen. Just the universe's starter ingredients burning hot and fast like cosmic matchsticks. You hover near one of these newly forming giants. It begins as a swirling cloud collapsing under its own gravity. The pressure rises, the center heats, and then without warning, fusion begins. Hydrogen atoms smash together, forming helium and releasing light. Brilliant, powerful light. And with that, the cosmic darkness ends. This era, called cosmic reionization, marks the re-illumination of the universe. The light from these first stars ionizes the surrounding hydrogen, stripping electrons off atoms, making the universe transparent again, but this time, due to starlight rather than cooling plasma. You watch as the blackness is slowly pierced by light. Stars form in clusters, clusters become galaxies. Galaxies merge into larger structures. It's still early, these are primitive, clumpy, chaotic galaxies. But they are there. The sky is no longer empty. And you're in awe. You've waded through fire and fog and silence to get here. And now the universe begins to sparkle. Truly sparkle. These first stars will live fast and die young, some exploding in colossal supernovae, scattering heavier elements into space. That's where the building blocks for life begin. Carbon, oxygen, iron. They're forged in these first stellar deaths. Your bones come from the hearts of stars that haven't exploded yet. Everything beautiful that you know, snowflakes, breath, curiosity, it all begins in the wake of the first stars. You float quietly, watching starlight crack open the night. The universe has finally woken up. You drift through the newborn cosmos as it slowly starts decorating itself. No longer a silent, unlit expanse, no longer just hydrogen floating in solitude, the universe has entered a new era. The era of galaxies. It's messy, it's crowded, and it's utterly glorious. The stars, those dramatic firstborns of the universe, are starting to do what all stars eventually do: die spectacularly. Their short lives, some only a few million years, end in supernovae, titanic explosions that fling their contents across space like cosmic confetti. And those contents, heavier elements: gold, oxygen, carbon, that's right. The carbon in your lungs, the iron in your blood, the calcium in your teeth. All of it was made in the hearts of stars that exploded billions of years ago. You are quite literally the aftermath of a stellar tantrum. Now, as more stars form and die, those heavier elements start to mix with the pristine hydrogen and helium of the early universe. New stars begin forming from this enriched material. These are the second-generation stars, cooler, more stable, more familiar. Some will last billions of years. Some are still burning today. You glide past them like a ghost. Watch as they huddle together in groups, galaxies drawn by dark matter scaffolding and gravity's persistent tug. Some galaxies are spirals, their arms slowly spinning like a sleepy pinwheel. Others are messy blobs, tumbling, colliding, merging. There's no elegance here yet, no majestic Milky Ways or perfect Andromedas. Just sprawling clouds of starlight in wild configurations. They dance. They crash. They devour each other. The early universe is not polite, but it's getting organized. Some of these galaxies are already pulling in satellites, tiny baby galaxies orbiting their older siblings. Others are shooting out hot winds of gas, pushed by massive black holes at their centers, roaring with gravitational hunger. Yes, the first black holes have already formed. These aren't the end-of-life black holes you might imagine formed from collapsing stars. No, these are supermassive millions or even billions of times the mass of our Sun, somehow already sitting at the hearts of young galaxies, like invisible kings on invisible thrones. Scientists still debate how they formed so early. Did smaller black holes merge rapidly? Were they seeded by direct collapse from gas clouds? Did the universe take a shortcut? Nobody knows. But they're there, lurking, spinning, growing. You pass one now. It's silent, perfect, a warping of space itself, and yet it shapes the galaxy around it, drawing in stars, gas dust, even light. It doesn't glow, but the stuff falling into it does. Accretion disks spiral, heat up, and sometimes burst with energy so intense they become quasars, the brightest beacons in the universe. And here's a brain-itching bonus fact for the night. A spoonful of neutron star weighs about 1 billion tons. That's a teaspoon of something so dense it would punch a hole through Earth like a bullet through tissue paper. Fortunately, you're not dealing with neutron stars yet. But they're black hole cousins. They're here shaping galaxies from the shadows. Meanwhile, gravity continues its quiet sculpting. Galaxies begin to form filaments, long thread-like structures, stretching across space connected by thin bridges of dark matter. Vast voids grow in between, like the negative space between brushstrokes. This is what scientists call the cosmic web, a vast network of structure billions of light years across, resembling a neural network, or a sponge, or a spider's dream. And you're drifting through these filaments, watching galaxies like beads on an invisible string. There's a rhythm to it, a geometry, as if the universe has decided it's time for structure. The light from these galaxies is faint, stretched by the ongoing expansion of space. Some of it will take billions of years to reach your future eyes, but it's coming. The sky is no longer dark. It's crowded, glittering, murmuring with photons that finally know where to go. And somewhere in one quiet corner of this still young universe, one tiny galaxy forms unnoticed among the others. It's not special yet. It doesn't shine any brighter than its neighbors, but it will one day become home to a pale blue dot. We're not there yet. But the ingredients are gathering. The spiral arms are just beginning. The gas clouds are waiting to collapse into a solar nursery that will eventually create you. It all feels far away. But the time between now and then, just a blink, cosmically speaking. The universe is not in a hurry. It's building carefully. Here's a lovely, sleepy fact for your subconscious to hold. Sea otters hold hands when they sleep, so they don't float apart. That's the kind of universe you're in now. One where galaxies are beginning to find each other, link up, and hold on. You're drifting through one such meeting. Two small galaxies spiral around each other like dancers, not yet colliding, just circling, drawn by mutual gravity. They will merge in a few billion years. Their stars will blend. Their histories will become one. And out of that collision, chaotic, beautiful, transformative, a new shape will form. Maybe even a spiral. Maybe even home. You hover now billions of years into the great unfolding, and something familiar is beginning to stir, though it's still impossibly far from your bedtime socks and streaming playlists. You're floating above a gas cloud, not just any gas cloud, but a calm, dense region spinning gently in one of those early spiral galaxies. It's no longer the chaos of the Big Bang or the lonely silence of the Dark Ages. It's the universe's teenage phase. Awkward, curious, full of potential. This cloud is going to become a solar system. Not just any solar system. Yours. Let's rewind time just slightly. You're about 9 billion years into the universe's history. The stars have been busy, forming, dying, exploding, seeding the cosmos, with all the heavier elements needed to make planets, oceans, bacteria, Taylor Swift albums, and whatever else fills your corner of the Milky Way. One of those seeding stars long gone now left behind a rich nursery of hydrogen, helium, and a sprinkle of carbon, oxygen, iron, silicon, magnesium, and more. A perfect primordial smoothie. Gravity, ever the behind-the-scenes matchmaker, starts pulling things together. The cloud contracts. It flattens into a disk. It spins faster. And in the center, a pressure cooker of hydrogen atoms fuses into helium, and boom, your sun is born. You float above it now, young and rowdy, flickering with energy, still wrapped in the leftover dust of its formation. It's loud, magnetic, temperamental, but it's stable, and it's here to stay. Around the sun, that dusty disk starts clumping again. Gravity never stops throwing parties. Some clumps become rocks, others gather gas. Some get ejected from the neighborhood entirely. But 8 major survivors begin to take shape. Yes, planets. Including 1/3 from the sun, the perfect distance for liquid water, with just the right amount of atmosphere, and a really solid record for strange life choices. But we're not there yet. Right now, Earth is just a molten proto-ball. It's being bombarded by debris from all directions. The moon hasn't even formed yet. Oceans, forget it. Oxygen, not even a whisper. Still, it's a start. And here's a spicy space fact for your dream file. Mars has the tallest volcano in the solar system. Olympus Mons, nearly 3 times the height of Mount Everest. Scientists suspect it formed slowly thanks to weak Martian gravity and a lack of tectonic plates to pull the crust around. So while Earth was melting and heaving and groaning with birth pains, Mars was busy building an absurdly tall mountain in complete silence. Back to Earth. The planet begins to cool. A crust forms, volcanoes belch. The moon is born out of a violent collision with another protoplanet, Theia, a fiery crash that flings molten rock into orbit. That debris gathers clumps and solidifies. The moon takes shape. Tides are coming. Rain begins to fall. Not a sprinkle. a global downpour lasting possibly thousands of years. The planet that was once molten starts to fill its basins. Oceans appear. Water, a molecule that came from stars and comets and chemistry, finally gets a permanent address. Then something outrageous happens. Life. We still don't know exactly how. Maybe it started near thermal vents in the ocean floor. Maybe lightning sparked the right amino acids in a shallow pond. Maybe the building blocks arrived on icy comets. Scientists still debate the details, but one thing's clear. Life didn't just appear. It persisted, from simple replicating molecules to cells with membranes, to the first photosynthetic organisms that slowly, over billions of years, poisoned the atmosphere with oxygen, which inconveniently is what complex life would eventually need. What a plot twist. Time races forward. You're still floating, watching this blue marble breathe and burp and slowly awaken. The continents move. Ice ages come and go. Life crawls from the ocean to land. Dinosaurs rule, then don't. Mammals try their luck. And eventually, the strangest organism of all appears. You. You with your soft limbs and reflective thoughts. You with your dreams and to-do lists. You made of the same stardust that drifted through quark plasma 13.8 billion years ago. You built from atoms that escaped annihilation, forged in dying stars, scattered by supernovae, recycled through planets and plants and pancakes. Everything that ever was led to you lying here tonight, blinking at the ceiling, wondering where it all came from. You are the thinking universe. The universe looking back at itself with curiosity, with questions, and when it remembers, with wonder. You are a child of that first white explosion, not separate from it, but continuous with it. Not just a witness, but a result. A conclusion still in motion. Here's a final little fact to hug close tonight. The atoms in your body are mostly empty space. If you removed all the space between the particles that make up you, you'd be smaller than a sugar cube, which means most of what you are isn't really there at all. And yet you feel whole, you feel solid, you feel here, and maybe that's enough. Maybe the universe didn't need to be explained, it just needed to be noticed. You're floating now inside a quiet miracle. The stars are out. The galaxies are woven into elegant filaments, and your blue planet is spinning comfortably in the Goldilocks zone of an unremarkably perfect star. Life has been around for billions of years, but something recent happened cosmically speaking. You began to notice, somewhere in the last few thousand years, after Earth's surface had cooled, continents had drifted apart. Fish had tried legs, and mammals had become strange little geniuses. Something opened in the brain of the universe. A new sense. You sitting there in the dark, maybe tucked under blankets, maybe wondering if this whole story is just the world's longest bedtime excuse. You made of particles that once floated through the cosmic soup are now asking questions about where you came from. And that makes you different. Stars don't wonder about themselves. Black holes don't ask where they go when they sleep. But you look up past the atmosphere, past the moon, past the scattered sunlight, and you wonder what was before all this, why anything, why now? Let's rewind the cosmic cassette once again. Humans haven't been around long. Our species Homo sapiens is a blink. Roughly 300,000 years. That's less than 0.002% of the universe's age. If the universe were a 24-hour day, you arrived in the final second before midnight, probably tripping over your own feet and yelling something about fire. And yet, look what you've done with your time. You built stories, languages, maps of stars, radios that catch the background music of the Big Bang. Particle colliders to replay the first billionths of a second. You figured out how to split atoms, grow tomatoes in space, and somehow get cats to meow into microphones for entertainment. But even before telescopes, you were looking up. Thousands of years ago, your ancestors stared at the same sky and told tales about it. Constellations became heroes, lovers, monsters. The Milky Way was a river, a crack in the sky, the spine of the night. You didn't know about quarks or recombination or baryon asymmetry, but you knew awe. You knew there was something out there, and more importantly, something in you that felt connected to it. Here's a thought to wrap your neurons around your brain, runs on electrical pulses and chemical gradients, just organized stardust firing in patterns. And yet from that soup of neurons rises a voice that whispers, "What am I?" And you're not alone. All across the planet, across cultures and time, humans have shared the same instinct to seek, to piece together the scattered photons of existence into meaning. Myth, philosophy, science, lullabies, all just ways of trying to touch the first light. Here's a deliciously irrelevant fact to sprinkle on top: trees can communicate. Through underground fungal networks, they share nutrients, warn each other of pests, and care for their young. You're not the only thing in this universe that feels connection. Even roots reach out. Back to you. Your species eventually built telescopes so powerful they could peer billions of years into the past. You found galaxies arranged like soap bubbles. You measured the cosmic microwave background. You built equations that described how everything began and might end. And the more you learned, the more stunning it became that from a universe born in total chaos, a creature emerged that could love. Not just survive, not just replicate, but care. Sit with another creature in silence. Cry at a melody. Wonder at a sunset. And most bewildering of all, make up bedtime stories about the Big Bang and whisper them into the dark for strangers on the internet. You are not just stardust. You are thinking stardust, feeling stardust, grateful stardust. And as you lie there now, your chest gently rising and falling in the dark. You're doing something the early universe never could, resting. All of that heat, all of that pressure, the white explosion, the angry photons, the rushing quarks, it brought you here, to stillness, to breath, to soft sheets and a strange, wonderful body that's mostly empty space, but somehow feels whole. Scientists still debate whether consciousness is a fluke or an inevitable consequence of complexity. But here's the secret you don't need to know. You're part of the story either way. Part of a process that began with a bang that wasn't really a bang in a space that wasn't really a space at a time that had just started existing. You are not separate from it. You are it. You are the Big Bang curled up in a hoodie whispering to yourself. You are 13.8 billion years of momentum resting in a single breath. And in this moment, this exact quiet moment, the universe is doing what it has never done before. It is listening to itself fall asleep. You are still drifting. Now the noise of the early universe has faded like fireworks long gone, leaving only the echo of its grand opening act. Galaxies continue to swirl and stretch apart like dancers moving in slow motion, farther and farther from one another, with every passing breath. And you're watching something new unfold. Time is becoming visible. Not as a clock on a wall, not as a schedule or a countdown, but as the shape of change itself. You're watching stars age, galaxies merge, black holes spin. You're watching the universe grow old. This isn't a sad thing, not yet. There's still so much brightness. But the seeds of aging are everywhere now. The hydrogen that fuels stars, it's being consumed. Slowly, relentlessly. The great cosmic fuel tank has no refill station. But there's peace in that too. Because even as entropy begins its long, quiet rise, even as the temperature of space gently declines and stars start counting down toward red giant dreams, the universe is still creating. In fact, you're still here. In a little solar system that's now mature, its planets stable, its sun halfway through its long, golden life. Earth spins on, and time does what it always does, it deepens, adds layers. And humans, those upright bags of animated carbon, keep evolving not just biologically, but mentally, emotionally, spiritually. You build stories within stories, and here's where it gets deeply strange. You begin to think about the future of the universe. You, not a deity, not a galactic entity, you curled up somewhere on a Tuesday night, begin to wonder what will happen after the stars go out. This kind of thought didn't exist for the first 13 billion years. Even dinosaurs didn't look up and go, I wonder about the thermal death of the universe. But you do. Because now the white explosion isn't just history, it's a question. What happens next? Let's fast forward. Hundreds of billions of years from now, star formation will slow, then stop. The great raw materials of hydrogen and helium will be used up. Stars will burn through their fuel, go red, puff out, collapse, flicker. Some will become white dwarfs, glowing quietly for trillions of years. Others will go supernova, leaving behind neutron stars or black holes. Some unlucky ones will collapse straight into black holes, silent, perfect vacuums of being. Eventually, there will be no new stars, just old ones. And then no bright ones, just the glowing embers of what was. It's called the degenerate era, a very dramatic name for a time when the universe is frankly just tired. Galaxies will thin out, solar systems will disband. Moons will spiral away, planets will wander. Even matter itself may decay, dissolving slowly into pure radiation and loneliness. Scientists still debate what will truly happen in the far, far future. Will protons decay? Will black holes evaporate via Hawking radiation, slowly leaking away mass until they vanish in a final poof? Will time continue forever? Will there be a big rip, a big freeze, another bounce? There's no certainty, just projections, sketches made with math and imagination. But even in those cold futures, something remarkable remains. You were here. A warm, sentient flicker in the long, stretching dark. A brief moment when the universe knew itself, when it could hold a book, speak a name, write a love letter, make a blanket fort, when it could play piano and tell jokes about quantum physics, when it could watch its own stars be born and wonder where they came from. Here's an odd and heart-squeezing fact to take with you into the next dream. There are more possible arrangements of a deck of cards than there are atoms on Earth. Shuffle one deck, and the odds are overwhelming that your exact sequence of cards has never existed before in all of history. You are that improbable. That once only. You, your personality, your memories, your fingerprints, your laugh are the outcome of countless collisions, coincidences, fusions, forces, and flukes, going all the way back to that first flash of brilliant nothing. And that white explosion, it's still going, because it never stopped. Every time you fall in love, or notice moonlight, or breathe deeply while watching the rain, the Big Bang is still echoing, still unfolding inside you. You're the localized continuation of its momentum, a pocket of complexity, a traveler carrying ancient energy in a bag of skin and questions. The universe is not somewhere you live, it's what you are. The stars will go, the galaxies will stretch, time will thin, but this one moment, your consciousness, your wondering you're here is proof that the universe made something that could care. You don't need to fear the end. You've already been through one. The first end, the one that began everything. And look what became of it. You're still here. The white explosion is 13.8 billion years behind you and eternity ahead. But you're resting somewhere in between. A soft, squishy bridge between nothing and everything. And now, as you drift even deeper into this quiet cosmos, you find yourself staring at one of the most bizarre truths of all. The universe is still expanding. You'd think after all this time, after all the galaxies formed, the stars were born and died, the black holes had their meals, the expansion would slow down, mellow out, maybe settle in for a nap like the rest of us. Nope. The expansion isn't just continuing, it's accelerating. Like a car that hits cruise control then just keeps pushing the pedal. Like the universe had a Red Bull and forgot when to stop. Why, we don't know. Enter dark energy. It sounds like the villain in a Marvel movie, but it's real. And it's everywhere. Around 1998, astronomers noticed something strange. Distant supernovae weren't slowing down like everyone expected. They were speeding away faster than they should be. The universe wasn't decelerating, it was flying apart faster and faster. Something was acting like anti-gravity, pushing space itself apart. That something was dubbed dark energy. Not because it's moody or mysterious, although it is, but because we have no idea what it actually is. It makes up about 70% of the universe. Yeah, 70. The vast majority of everything is this thing we can't see, can't touch, and barely understand. It doesn't clump like matter. It doesn't interact with light. It doesn't come in particles. It just is quietly stretching the fabric of space-time. Some scientists think it might be the energy of the vacuum itself. Others believe it's a property of space, or maybe a fifth force or a quirk of gravity on the largest scales. There are theories, equations, models, but no answers. You're floating now in a universe that's not just getting bigger, but getting bigger faster. Every second, the space between galaxies grows, not because they're flying away from each other, but because there's more space appearing between them. Imagine you're lying on a rubber sheet, and someone keeps inflating it from underneath. You're not moving, the ground is, and the farther apart 2 points are, the faster they separate. That's how it feels now. The galaxies you saw earlier dancing, colliding, forming clusters are drifting apart. Soon, many of them will slip out of view forever. Their light, stretched by expansion, will no longer reach us. Not because they vanished, but because the space between us expanded too fast for their light to keep up. Eventually, our sky might grow emptier. Not darker, there will still be stars for a long while, but lonelier. Other galaxies will become invisible. The universe will horizon off like islands disappearing into mist. Here's your pleasantly weird fact to chew on while the galaxies fade. There are mushrooms that can glow in the dark. Bioluminescent fungi, found in forests, glowing softly on the forest floor. You are not the only thing in the universe that insists on producing light in the middle of darkness. Back to the stretching. The implications are wild. If dark energy keeps accelerating the expansion, then one day in the far, far future, everything not gravitationally bound, everything not nailed down by gravity will be flung apart. Galaxies will isolate. Star systems will isolate. Eventually, only the local group, our Milky Way, Andromeda, and a few dwarf galaxies will remain visible. Everything else will be gone beyond the cosmic horizon. And maybe, just maybe, in a few trillion years, a lonely civilization in one of those galaxies will look out at their night sky and see nothing. No evidence of expansion. No cosmic microwave background. No galaxies to compare motion against. They might conclude they're in a static, eternal universe, because all the clues will have been stretched away. You right now are lucky. You live in the observable era. You can still see the past, still detect the echo of the Big Bang, still witness the clustering of galaxies and the accelerating future. You are a creature born not just of stars, but in a time when the universe can be understood. It won't always be like this, and yet there's beauty in the unknowing. Because even if the universe slips beyond our observational fingertips, even if dark energy stretches the stars into silence, you'll still be part of it. Your atoms will still float. Your photons will still bounce. Your choices, your breath, your laughter, they echo through entropy written into the heat. The Big Bang gave you mass, expansion gave you room, and dark energy, it gives you drift, a gentle stretching of all things, a reminder that stillness is temporary, that even silence can have motion, that even now lying still in your bed surrounded by soft breath and fading thoughts, you are moving. Every second, every cell, every bit of you is drifting farther away from what was and toward what's next. You're still moving. Not just you, the whole universe. Everything is sliding outward faster and faster on a ride with no visible brakes. It's not violent, it's gentle, like sleep, like falling, like a breath exhaled too slowly to notice. The white explosion you started in is now a whisper behind you, its light stretched thin across space-time. The galaxies are ghosts now fading into red-shifted silence. The night sky you once admired is slowly going dark, not because the stars are gone, not yet, but because their light can no longer reach you. The cosmic isolation has begun. And here's the beautiful paradox: even as the universe grows colder and quieter, your understanding of it is warming, deepening. You know more now in this quiet moment than the entire universe knew for its first 10 billion years. Because now you know the end is coming, but not quickly. You're drifting toward a time called the heat death, or the big freeze if you prefer your metaphysical endings with less drama. This is the fate of a universe ruled by dark energy where expansion never stops and entropy always wins. Here's how it plays out. First, the stars die. Not in a mass extinction, not with drama just one by one running out of hydrogen. Some will go red puff out and collapse into white dwarfs. Others will explode, leaving behind neutron stars or black holes. But eventually, no new stars will form. The fuel runs out. Galaxies will dim. Then come the quiet centuries where white dwarfs cool and fade until they become black dwarfs, theoretical stellar corpses that no longer emit light. They haven't had time to form yet. The universe isn't old enough, but it will be. Trillions of years will pass. Next, the planets drift. With no stars left to orbit, they become rogue wanderers, cold, dark marbles in a universe with no sunrise. Moons will go silent. Oceans will freeze. Then the black holes evaporate. Even these gravitational monsters, so confident, so eternal, will leak energy over time through Hawking radiation. They'll shrink, fade, until they too vanish into nothing. All that will remain is radiation and subatomic debris spread thin across an unthinkably large cosmos. A few lonely particles moving slowly through nearly absolute zero. No light, no heat, no structures, no story. Just the universe finished. And yet, even in that cold vision, you find something oddly peaceful. A sense of completion. Like a song that has played every note it ever meant to play. Like a fire that warmed the room, then gently went out. You are here after all. On the timeline. Not after the ending, but during the golden moment when stars still shine and thoughts still happen. This is the age of light, and it is a rare, precious blink. You are alive in the most visible, most expressive, most curious slice of cosmic time. And you're using it to listen. You're using it to wonder. You're part of the universe thinking about itself. That, by the way, is not metaphor. It's literal. The same hydrogen that hummed in the first few seconds of the Big Bang now vibrates in your cells, listens through your ears, spins stories through your neurons. The universe was once mute. Then it screamed. Now it whispers through you. Here's a final bedtime fact to settle you in some scientists. Think information can never be destroyed. That every interaction, every quantum event, every memory, even the ones long forgotten, still exists in some encoded form in the universe. Which means nothing, not a thought, not a hug, not even this moment is truly lost. It's all stored. Somewhere. So even when the last star fades, the echo remains. Your molecules might scatter. Your atoms might be repurposed. But your existence, brief, brilliant, and deeply improbable, was recorded. The white explosion began it. But you are part of how it knows it happened. And in that way, you're not drifting from the Big Bang. You are the Big Bang. With ears, with memory, with dreams. So lie back now, traveler. Let the expansion carry you. Let the cooling stars sing you to sleep. You've come a long way from lightless beginnings to awareness, from stardust to stories. The universe is quiet now, but you're still glowing. You're floating now through the final light. Not the blinding white of the beginning, but a softer, scattered glow, the slow-burning afterparty of existence. A few stars still shimmer. A few galaxies still pulse. But it's quieter. The universe is no longer in a rush. The drama has passed. This is the epilogue of everything. And you, strangely enough, are still here. Still drifting. Still wondering. Still warm. Let's take one last look back. Remember the beginning. That unbearable flash of brightness that wasn't really light, that wasn't even really a bang. That moment when time clicked on, when space inflated, when matter and antimatter fought their one-sided war, that wasn't just history. That was the first word in the long, strange sentence that eventually became you. You followed that sentence across 8 billion years from violent plasma and quark-gluon chaos, through fog and sound and starlight, through galactic collisions and black hole formation, all the way to consciousness and questions. And now, in the ever-cooling silence, you're watching the universe remember itself. You are made of remembering. Every cell in your body is a whisper of earlier physics. The hydrogen in your blood was born in the Big Bang. The calcium in your bones was forged in ancient stars. Even the electricity crackling through your brain is governed by the same quantum rules that shaped the very first atoms. You are in every possible sense the current shape of the explosion. And even as everything slows down, even as the last stars fade and gravity finishes its grand experiment, there's something comforting here. The story was told. Not just lived, understood. You understood it. That's the miracle. That's the unexpected ending. The universe didn't just create particles and light and galaxies. It created curiosity. It created listeners. It created storytellers. And now, after billions of years of chaos and order collapse and expansion, silence and sound, you lie here listening. Not for answers necessarily, but for connection. And here's one last wonderful fact you can't unexist. Even after your atoms are scattered, after your body rests and your voice stops, you will have happened. That's permanent. That's burned into the record of time. There was a you. A soft, remarkable thinking spark in the vastness. a moment of awareness that no entropy can erase. So when you feel small, remember the universe didn't need to give you the ability to care. It didn't have to make beauty visible or love possible or questions so irresistible. But it did. And maybe that's the point. Not an ending in fire or cold, but a middle. A bloom. A whisper that said, you were here, and you saw it. So close your eyes now. The stars are still humming. The galaxies are still drifting. The explosion is still echoing somewhere deep in the bones of space. But you're allowed to rest now. The story will keep going, and you were part of the page. You made it. You began in a white explosion that wasn't really an explosion, just a brilliant silent burst of being where time, space, and energy unraveled from nothing. You drifted through the Planck epoch, where physics hadn't picked a rulebook yet. You watched quarks form forces, split particles, dodge annihilation, and matter narrowly win against antimatter. You floated through a universe that had no color, no stars, no structure. Then came the light first, trapped, then free, marking the moment the cosmos became transparent. Galaxies formed from that first echo, sculpted by sound waves and shadowed by dark matter. You watched stars ignite, planets coalesce, and carbon stretch itself into the shape of life. And then somehow life began to wonder. About itself, about time, about what was before everything. You became the voice asking those questions, the eyes peering back 13.8 billion years, the mind capable of both awe and silence. You learned the universe is still expanding, still accelerating, driven by a mysterious dark energy we barely understand. And you saw the long future, a cooling, quiet cosmos where stars, dim matter dissolves, and even black holes fade into nothing. But through all of it, you endured. Not forever, but long enough to know, to think, to feel. You became the moment when the universe noticed itself, when it whispered, I was here. So tonight, as the last of this story settles in your thoughts, know that you're not small. You are the newest edge of the Big Bang, a consciousness made of hydrogen and history, a question suspended in stardust. And that is more than enough. Now drift softly into the dark. You've traveled a very long way, and the universe is still holding you. End of script. Good night.